On today's episode of Keystone Brain Bytes, we're talking about the vestibular system and its relationship to cognition and memory. So when we think about the vestibular system, those are our little nerves and our organs inside of our inner ears. We usually think about dizziness disorders. We usually think about things like vertigo, because when people have vertigo, they're usually going to associate with either crystals inside of the inner ear system, or they're thinking about an infection of one of the nerves inside of the inner ear. So it is a well-established fact that problems within the vestibular system are going to lead to problems with your balance centers. But one of the things that isn't really well known, but is fairly well established inside peer-reviewed literature, is that the vestibular system is highly related towards your ability to think and cognition and memory. This actually dates back to early studies done on rats, where when you took a rat and you actually either chemically poisoned the vestibular nerve, or you actually took the vestibular system out of the rat, that mice had a really hard time getting through mazes. What they also noticed is that these same mice would also have difficulty returning back to their home. They would have difficulty remembering where food was. So there was something bigger at stake than just figuring out how to navigate a maze. These mice were actually not able to think in the same way that they would if they had a fully functional vestibular system. And when scientists actually dug into this a little bit more, they saw that whenever your vestibular nerve fired, there was actually a relationship with the vestibular nerve firing into the brainstem and actually its relationship to other higher levels of the brain, particularly in a part of the brain called the hippocampus, which is where our ability to form new memories sit. And the interesting thing about that is that when we look at the hippocampus and the vestibular system, it actually gives us a sense of spatial orientation and spatial memory. And a big part of that is because when we look at our vestibular organ, and you can see this nice little model from Vestibular First, is you have these little rings here, and those are called your semicircular canals. And these semicircular canals actually point in different directions. So some semicircular canals are pointing forward and back, which they activate whenever we move our head forward and back. That gives us a sense of what's in front of us, what's behind us, and what's on top. We also have canals that give us our sense of left and right, and we also have canals that tell us our sense of tilt. So these canals really give our brain information about the location of the various objects in space relative to where we are in space. So when we don't have a fully functional vestibular system, then we are missing some of the directional sensors that we rely on in order to figure out what direction that we are going. So the key factor with this is the hippocampus relies on these signals coming from those semicircular canals, and when we lose the afferentation or the stimulation coming from those canals, then the hippocampus is not getting a necessary form of stimulation for the development of new neurons and new connections inside of the brain. So what does this mean in humans? We know that it does severe problems in rats, but what about humans? A lot of humans will get vestibular loss from something like a vestibular neuritis, but they don't necessarily have this issue of getting lost. But there are studies in patients with Alzheimer's disease that notice that when patients have a history of vestibular loss, particularly bilateral vestibular loss, that there's a higher propensity for those patients to have a spatial form of Alzheimer's. And these Alzheimer's patients are people that tend to go get lost or tend to forget what direction that they are going. So these patients lack some form of spatial orientation, which then turns into a loss of spatial memory. So what does this mean long term? It's hard to say. We don't know if this is something that can be modified by improving someone's vestibular sense. We don't know if this is something that can be modified by doing vestibular rehab, but it does open up windows into things like traumatic brain injury, where people have known vestibular issues after a traumatic head injury, and we do know people with traumatic head injury do have cognitive and memory issues as a result of that. And some of these samples that we've seen in offices like mine, where we do functional neurological rehabilitation, is that when people perform poorly on cognitive testing and we do rehabilitation and get them feeling better and get their brains working better, that they also tend to perform better on a lot of these tests of spatial recognition and spatial orientation. So we do know that intervening at the level for traumatic brain injury patients that we can affect these scores on cognition. And it's yet to be seen if this was going to have a lasting effect on potentially affecting patients with long-term issues like mild cognitive impairment or potentially dementia. But stay tuned. This is something that I think is going to be a fascinating area of research in the coming years, where we could see the potential effects of doing something like a vestibular implant for vestibular patients, or doing things now that vestibular rehabilitation is more prevalent. We could see if adding a vestibular rehabilitation component into people with vestibular loss might be something that helps to mitigate or change the dynamic of the amount of patients that will go on to develop something like Alzheimer's disease. Hope you enjoyed that episode. If you like what you saw, then make sure to subscribe to our YouTube channel or follow us on our Instagram page and get more content like this on a regular basis.